Good afternoon and welcome back to the workbench. Today I have here a little power supply, a little adjustable power supply sort of thing that I purchased for $1 second hand. I always like this old Dick Smith stuff. I have fond memories of Dick Smith, the shop and everything, because that's the Funway series from him was what got me into electronics. So I have quite fond memories of that. As you can see the logo there, if it'll focus. Yeah, there we go. Classic old Dick Smith logo. So this is an M-9630. It's a adjustable power supply. It can do 3, 6, 9 and 12 volts, and it claims to be regulated. It also says it does up to 900 milliamps output. And this label on top here says that it will tolerate overloads and short circuits for brief periods. Which is a little bit confusing, so I don't know what's going on here, if this is actually regulated or not. I guess I'll find out because I'm going to open it and have a look. I also don't like the look of these screws. They're very rusted, obviously, and maybe I can replace them with something else, possibly some actual binding posts, or just replace the screws with ones that aren't rusty, at the very least. It's got 3 screws on the bottom to hold the case together. There's one at the front and 2 at the back there, all very simple and basic. It's a decent size, you know, fits in the hand, but it's got a little hole at the front here. I don't know what that's for. If that was for an indicator LED or maybe a optional DC jack or something output, I don't know. Yeah, it's got a standard mains lead at the back there. No fuse on the primary or anything. There's no fuse holder there. There might be a fuse on the inside, I don't know. I don't have a manual for this at all, and it looks pretty old. I don't know if I'd have a catalogue old enough to show a picture of this and whether or not it has anything in that hole. The mains plug is the old style type, so you know that dates it back to fairly old. It doesn't have the insulated pins for safety, and these ones are a little sort of corroded. You can see some kind of sort of pitting and maybe verdigris starting there, some kind of corrosion there. So this plug is a little bit crusty. It maybe could do with being replaced. Again, it's not up to code for the current era, and it's also a little bit on the dodgy side in terms of corrosion. And not that it would be, you know, unsafe to use in this state, but you don't want to get corrosion on your sockets or whatever and cause issues further down the line. It's better to have a nice clean plug. So I may swap that out for something else. But anyway, I just want to see if this thing works. I was told it was working by the seller, but I want to test it out and I want to have a look inside and see if it is regulated as they claim, and if so, how. We have a 4-position switch, obviously, for the 4 different voltages. And I can see a linear transformer if I look through these vents here. But I can't tell whether it's a multi-tap transformer, and this switches between taps. If it was simply that, then it wouldn't be regulated. And perhaps it switches between taps, and also there's like a LM317 in there, and it switches between resistors on the feedback pin. It could also be very basic and might just be a pass transistor and a Zener diode, and there's just 4 Zeners or something that it switches out the circuit. I don't know. If it's a single winding transformer and this adjusts a regulator feedback or something, yeah, I mean obviously there's a big power drop differential between 3 and 12 volts if you're running the full output current, but who knows. But we'll have a look inside and find out. Let's see, I don't know if this screwdriver will fit in the bottom. It fits in the front screw, but it may not be. Oh no, the screws aren't too deep. I think this will work just fine. These don't look like they've ever been taken out before, which is nice. So this thing should all be original with whatever it is. What have we got here? That actually looks like a pretty decent design. I quite like that, except for the fact there's no primary fuse. It would appear, possibly. Yeah, I can't see one there really at all. Those wires there just go straight into the transformer. So this probably does have a thermal fuse or something fitted, but there's no like primary direct fuse at all. There is, let's see, yes, a 3-pin regulator, probably a 317. I can't really get it under the camera. When I do notice something, there's a little bridge rectifier there, one of those round ones, and it looks a bit dodgy. It does appear to be a multi-tap transformer though, so I'm guessing that this switch here does switch between taps and also between feedback resistors. I can see at least 4 of them under that heatsink, so yeah, I think that's how it's being done, which makes sense. That's the most logical way to do it. Multi-tap transformer and regulator with multi-voltage setup. And these little stud things just press fit into the plastic there, it looks like, so it probably would be fairly easy to remove them and put binding posts, but you probably could just take these screws out and replace them with brand new ones. It looks like the contacts underneath are fine. I'll take those out and just see. Yeah, the screws are definitely rusty, but the terminals underneath don't look too bad at all. I mean, there's a little rust on the threads inside, but the actual contacts there are not bad. So yeah, like a new pair of new screws on that. They look like M4, I think. Could probably easily fit something else on there if I wanted to, or like I said, take that out and put a binding post instead. There is a spider nest there. Amusing. Probably came in through that hole right next to it. What else have we got? Like I said, we have a bridge rectifier that looks like it's been damaged. Let me see if I can get a close-up of that. There is a crack in the top of it. And that is quite amusing, because the seller did say that they'd been using it as a battery charger, so it's entirely possible that this has overloaded the bridge rectifier and burnt it out. Yeah, not sure how easy it is to see that, but there is like a little crack running along the top of that rectifier, and it's sort of domed on top and bulging, so that's definitely, at the very least, damaged and should be replaced. We got a little trim pot there, we've got a little capacitor, probably for stabilizing the feedback voltage. We've got 2 resistors over here and another 2 on that side, obviously switched. We've got a diode, which is probably a protection diode for the regulator, I think. So you don't backfeed power into that capacitor and cause damage. The capacitor is a 2200 microfarad, 25 volt, Wisdom brand, which I've never heard of, but I think I've seen a couple of those before and stuff from this era. And there's a little 100 nanofarad monolithic cap, probably in parallel with it, probably on the input to the regulator, although you'd think that capacitor should be all the way over here and physically closer to the regulator would make more sense. But yeah, it's pretty simple. It's pretty much exactly what I thought it would be. Yeah, I couldn't imagine what else it would be, to be honest. But there we go. That seems like a decent design. I'm pretty happy with the design of it, but I definitely need to have a look at that, and I'm glad I did before I powered it up, because who knows what the state of that is. But I guess what I have to do now is get this thing out and see what that bridge rectifier is doing, seeing if it's shorted or open or what. There's a screw here holding this board into the case, and that looks like about it, really. That just comes all out, and then this transformer is just sitting in this little bit there with some tape around it to keep it steady. Pretty simple and fairly logical design there. That's a very handmade circuit design. PS501. It's even got a hand handwritten number in the solder mask there, taped out by hand using those little graphics packs that you used to be able to get, that no one uses anymore, obviously, because now we all use CAD software. Now the switch has two sections. As I expected, this section here goes to the input taps for the transformer, and the section here goes to the various resistors. So yeah, that's exactly what I figured. I don't know if the regulator will be okay if the bridge rectifier is bad. So this is the bridge rectifier here. It's negative on here, which means that's our AC, and that's our positive output there, and that's where that cap is. Alright, so let's measure this and see what we get. Let's see, I think we got positive on there, and yeah, we got a diode drop, 488 millivolts there. We should get one from here as well, 488. Okay, and the other way around, we should get 500, and we've got 500. So this bridge rectifier is actually testing fine. Nothing is obviously bad here. And strangely enough, because yeah, we've got we do have a big crack in the top of it. So I definitely want to replace that though, because even if the silicon inside is still fine, which it appears to be, it's obviously suffered some kind of overheating problem at the very least, and if the plastic is cracked, then you know, moisture can get in, there can be an issue with that, and the silicon inside is probably going to fail anyway. So I believe removing that and replacing it is obviously the logical course of action. I don't know if I have one of those bridge rectifiers on hand, but that's interesting. I'm surprised. I thought that would be open circuit or possibly shorted, going by the appearance of it. I wonder if the regulator is okay. It probably is then. If the regulator is yeah, 500 millivolts there. Millivolts there. The regulator is probably fine. Yeah, nothing showing up strange there, which does make sense. The bridge is not shorted. If the bridge was shorted, the regulator might be bad, but apparently not. Of course, that bridge could be leaky as well. That's a possibility. Might be damaged, and therefore the diodes could be leaky. So you could be getting not quite DC on the output. You know, it could be going negative into AC as well as possible. The simple diode test like this doesn't prove that much. Obviously, you really need to run it under load with full voltage to see if it's performing correctly, or obviously test it on a curve tracer or something, which I don't currently have. That capacitor, the main filter cap, could be damaged if the bridge rectifier was leaky, possibly, but it doesn't look bulging or anything. It looks okay, so I don't expect it to be an issue. Just trying to think about these. The holes in this case for these little mounting terminals are I could probably get binding posts in there if I put a washer under the nut or something. It should be doable. It would actually definitely be better than these things. Screw terminals are not that great. It is nice to have a decent connector on there, so I probably will try and do that at some point. If I can figure it out, if I can get ones that screw on there pretty well. You just got to get ones with a big nut, I suppose. Some of them have small nuts, some have big nuts. It all depends on the design. And then maybe if I can figure out a decent way to do it, I'll test the bridge and for a leakage test and see if I can find anything wrong with it. Yeah, I do wonder if the seller possibly used it as a battery charger, overloaded it for a while, the rectifier sent out some smoke perhaps of the plastic, and then they decided to sell it for $1, because even though it probably still worked, they just didn't want something that smoke had come out of, which yeah, a bit dishonest I suppose, potentially, if that's the case, but I don't mind because it's obviously an easy fix, and this is a nice little power supply other than that. I do have some screws here, these ones here, which I could possibly use to replace those terminals with, but these are not Phillips, they're like hex head bolts, so even more inconvenient than the originals, but at least not rusty, so that might be a good start to be able to use the thing. Yeah, it looks like these two should fit in there. Oh, maybe not. I thought these were M4, but they possibly are some Imperial thing. No, yeah, that jams. It threads in almost and then jams. Yeah, these are definitely different. I think this top one's actually possibly tapered, but yeah, it looks almost like an M4, but the threads I think are a little bit spaced a little bit further apart. And yeah, this is possibly some Imperial thing, which I doubt I have, so that's an even better reason to replace it with binding posts, because finding out what's finding out what screw yeah, finding out what screw would actually fit that without a thread gauge or anything, which I don't have, would be a bit tricky. So yeah, I think replacing these with binding posts is probably the best idea, and would definitely be a better option than a screw terminal. So there we go, that's what to do with it. Let's replace that bridge rectifier, and let's replace these terminals because they're a bit not great. One final thing about the build quality of this thing, just before I go off and try and find some parts for it, I noticed here that the regulator is not actually sitting flush against that heatsink. The tab up there is fairly decent, but it's obviously bent over slightly, but the rest of the body is actually got a big gap there. That hole for the heatsink should be drilled up higher up here so that it's closer to the top and to actually clear this bend, and yeah, anyway, it's terrible. Pretty bad build quality in terms of that, well, bad assembly I guess. Everything else is probably fine, but yeah, that's not great, is it? So yeah, not the best build quality I guess, not the best assembly quality overall, but still not terrible. Basic design sort of thing. I might be able to fix that too, I guess. I could possibly re-drill the hole, move the regulator up a little, or possibly put a shim of aluminium between it and the heatsink proper, so we've got it raised up and therefore clears that bend at the bottom. Yeah, the bridge rectifier definitely needs to go, because that's definitely not trustworthy at all. I can get a new one of those for $1. I didn't have any, so that's not too bad, but yeah. And the binding posts, a couple of dollars for that, so yeah, I don't actually have any of those on hand, but I should be able to get some very easily and fairly cheaply, so yeah, it's not a bad thing overall. This only cost me $1 and put a few dollars of parts in it, and should be making a half decent little adjustable supply, even if it's not adjustable between 4 fixed voltages. It's still pretty good, because they're pretty common voltages that most people would want. 6 volts I guess is a bit off there. 5 volts would probably make more sense. 3, 5, 9 and 12 are probably quite good, but yeah, we'll see what happens. I might do a little bit of work on this and get it up to speak a little better. Overall around a pretty interesting little thing. I didn't expect I'd get something this interesting out of a $1 purchase, but here we go. It's fairly amusing so far. So I'm back with the new parts. As you can see here, I got 2 binding posts, I got a new bridge rectifier. I also bought a new capacitor and a regulator, just in case. The capacitor I well, I'm pretty sure I will replace that anyway, because I looked at the old one, and when I looked closely at it, I noticed that the negative lead was actually a little bit corroded and looked a bit funny, so it's possible that it has been damaged by reverse voltage, or maybe just old age, I don't know. This thing is probably, like I said, I don't know, from the 90s, so it's going to be like potentially 30 years old or something. So yeah, decided to get a new one of those to replace that. And yeah, I got a new regulator just in case this one's damaged, either physically by being mounted in this bad way, or electrically by maybe the leaky bridge rectifier or something. I don't know. It could be leaky. It tests fine, you know, no shorts or anything, but don't know. Still suspicious. So it is possible I'll need to replace all of those anyway. But we'll see, and I might try and do something with this heatsink situation and make it a bit better. Either way, if I did just move the regulator up the heatsink a little bit, I don't know if the legs would be long enough to go in the holes, so I probably need a new one anyway, even if this one's fine. The only thing I noticed with these is the binding post may extend further down inside the case than the solder tags on these screw terminal thingies, which means I might need to mount these further out by putting a second nut and then having that on the front side. Fortunately, I do have a few of these that are stripped because they're just not that great quality, and I do have spare nuts, so I should be able to do that and it should be fine. And that's a good point about these, which I've noticed, like they're okay in terms of how they work, but I think it's this split washer here. You need quite a good amount of force to bring that together, and if you can even see, you know, these edges are kind of overlapped. To push that down requires quite a bit of force, and it's more force than these threads can handle when you're screwing the nut on. So I think it might be wise, if you are using these kinds of binding posts, these cheap ones from JCar or similar from anywhere else, is to possibly get the split washer and squash it down a bit with pliers first, just to make sure it actually moves, and possibly bend it a bit so that when you do go to put them on, they actually do squash down. Yeah, I mean, I don't think you really need that much tension on it anyway, and it's actually too much tension, I think, for the threads in this plastic. So yeah, if you can just squash these flat or something, or even use a different washer, it's probably fine. I don't think it needs that much tension on it. The only other thing is I may need to enlarge the holes for these. The holes do look about the right size already, to be fair. The threads look like they're about the same, but I might need to file away some of the plastic there just to get the binding post to fit. So I'm not sure if that's necessary or not, but it might be. If it is, that won't be too hard. I've got some little rat tail files there that can do that easily. But yeah, that's the next part of this. Replace all these parts and add these, and then we can give it a test and see how it works. I don't really want to test it as is. I don't want to risk damaging the transformer in case the bridge rectifier does go dead shorted suddenly and, you know, burn something out. I don't know. Unlikely, but still, you know, why bother risking it? The transformer is the bit we can't really replace because it's you know, special multi-tapped, and to try and get one that would fit in here would probably be impossible because the exact size would be not the same. Alright, so let's turn this thing over again and start removing these bad bits. So nothing particularly complicated about removing these. It's a very simple single layer board, so a standard solder sucker should be fine. So I'm just going to flow some fresh solder onto the joints that I wish to desolder. That usually helps. And of course this is all leaded solder on here already, so it does make it a lot easier to work with. I will of course verify how the bridge rectifier is situated. We got the positive there towards the switch here, the negative faces this trim pot, and yeah, so that should be fairly easy to do. So this should come out now. Capacitor, yep, that comes out there, and I'm not sure, but you can see the negative lead has quite a bit of corrosion on it, and possibly more than the positive, so I don't know. Maybe it's worth replacing it. And then the bridge rectifier here, it's in there quite tight because the leads are bent. The pads are not exactly aligned with the way the thing is. And you can see there's definitely damage on that. Definitely a crack in the top there. Even though it's testing is okay in diode test mode, it might be breaking down under load and leakaging, or passing some amount of AC, so I wouldn't trust it when it looks physically damaged like that. At the very least it's overheated so much that it's bubbled the case up, and that isn't going to say much for its longevity, so yeah, not really worth it. Just better to replace it with a brand new one. Yeah, the holes on this PCB are much tighter than the spacing on these, so that's not a great design either. You can see how much they've bent the legs over on the left one compared to a new one. It's very very bent over. So the positive leg faces the switch. Just put that in there. Now again, you want to bend these not right next to the body of the component, because you can cause damage there, and then bend those out a little bit there. Getting this back into here, lift the transformer up a little bit. And, this capacitor is slightly longer than the old one, but that's okay. It's not going to be an issue. I'm just going to solder it in like this. It's not going to be flush against the board, but then I can push it down into the correct position and reflow the solder, and then we can do that with the other side, and then solder this rectifier in. That can be sitting up off the board anyway, because that has better cooling for it. Of course, we do have to make sure it's not touching the side of the switch and shorting out on that, so just push it over a little bit. There we go. Clears the side of the switch. Now I shall trim the leads off. And now, just to be extra special, I'm going to reflow these joints again. And we actually coat the cut end of the lead with solder. Whoops. To make sure that it doesn't corrode. And where the plating has been cut. And I have just bridged one of these pins on the bridge. So we'll suck a bit of that off. And there we go. That's good. That's fine. Okay. Right, so that's good enough to test, I think. We can find out if the bridge rectifier, if the regulator is good or not. Just like this here. And whether or not we need to replace that. Okay, I've got it plugged into my load here, and I'm just about to plug it in. So I've got the switch, should be set to the 3 volt position, so we should see about 3 volts on there. We should see pretty much exactly 3 volts, because it's a decent regulator, or at least it should be. And yeah, let's see what happens. Yep, 2.96, that looks pretty good to me. So that is working. Let's see if we can load this up a bit. It's supposed to be able to do 900 milliamps. It does drop a little bit, but I don't know if that's the regulator at fault or if it's the these crappy connections here. Might not be the best. I don't know if my clip leads are very good, to be honest. Let's try a different voltage. Try the next one up. That should be 6 volts. Yep, 5.8. It's a little low. It's getting a little warm. I don't know if that voltage is accurate though. That should be 9 volts. We get 8.7, 8.3 at full load. That might be normal. This is a fairly small transformer, so it might just be going down a bit. And that should be 12 volts. 11.6. Everything is on the low side, although there is a trim pot for adjustment there, which might need to be adjusted. Or maybe the resistors are out of spec a little bit, or my test leads are just rubbish. Oh wow, yeah. That bridge rectifier gets really hot at that full load. No wonder the other one has a crack in it. That gets pretty warm too, but not as warm as that does. The bridge rectifier really should have its own heatsink, to be honest. In fact, maybe that's where the voltage drop is coming from. I'm going to try measuring the voltage at the terminals and see if there's any difference. Let's see if it drops as much on the other meter as it does on here. Oh yeah, it's about the same. It drops less on there, which makes sense. But yeah, it's still dropping a significant amount. I'd say this thing's okay, but it's probably not good for a super high load. It's a pretty basic thing. But yeah, I don't like how hot that bridge rectifier gets. That might just be the way that it is. There's probably not a lot you can do about that unless you mounted another one on this heatsink or something and ran wires there, which I guess is entirely possible, but I think it's best to just use this thing not at full capacity, I suspect. But yeah, now that we know that the thing actually works, obviously, it's not perfect, but it works. I can go ahead and put these binding posts in. I think that's the next logical step, which involves removing the old connectors here, and I think I can figure out how to do that. So it looks pretty simple actually. We have these let's see, we have these contacts, these kind of little V-shaped bits of metal that look like they're pushed into the plastic and then splayed over a little bit to make a friction fit. So I think really all we need to do is just squeeze those back together and then it should just drop out. Should be an easy way to get those terminals away. Just grab those, squeeze it together, and I can probably just push these out of there, I think. Anyway, I don't care about breaking these terminals because I'm not going to use them, they're not very good. Yeah, there we go. Take that out of there and pop those out just like that. I also wanted to pop them out before I desolder the wires because I don't want to risk melting the plastic or something while they're in the thing. Desolder those fairly easily. I'll just hold it with the pliers. That on there, and let's see, does that go through a hole? Oh look, it goes through a hole. Of course it does. Let's just move that down here. Then we can flatten this wire. Or at least try to. Can I do that? Yes. Okay. And then heat that up and pull it off. There we go. And then to make sure this contact's going to be boiling hot, so make sure it cools down first before you set it down on something that may burn. That one's quite well wrapped over though, annoyingly, so I don't know how easy it will be to undo this one. The wire is folded over much more than the other one, so maybe I can lever it out like this. The soldering iron on it. Yeah, there we go. There we go. Got it out. Wonderful. Blob of solder on there, but that's fine. And those go away. Alright. So now we can take this off. Get rid of that spider web stuff. And we're left with two holes there, which, like I said, look like they may almost already fit these. It's very close. Yeah, I just need to slightly enlarge that. Very slightly. Just file the little points off, I think, around the edges there, and it should just go straight in. And then it's a case of soldering these onto the new ones. So first of all, anyway, I need to file these so these fit in, and I'm going to do a clearance test between that and the bottom of the case to make sure that these aren't sticking out too long, and if they are, I need to go find some extra nuts for these to put on. Yeah, alright, so there we go. I've filed out one of them, and you can see the difference here. I've just basically filed all those little corners off. But I've left enough there so that it can easily, it still goes in there fairly tightly. And yeah, fits pretty well. Obviously that's the wrong terminal for that one, that's for positive, but either way you see that it fits, and it's still got a bit of resistance there when you put it in, so it's not like super loose or something. So yeah, it's just a case of getting one of these little files here and just filing it down like this. And just keep going and keep test fitting it, and you'll see where it's jamming, and just go slowly. You don't want to overdo it and cut out a big hole and then it's all too loose and you can't actually use it. But yeah, start off. I'm using a half round file, flat on one side and round on the other, so I'm filing down flat to begin with, and then using the round one to change the shape there. And if I do a test fit here, you can see it obviously doesn't fit yet, so then I take a little bit more off. Obviously I already know what I'm doing because I've already done this one, so I've got a good idea of what the second one needs to look like. It looks about right there, I think. Do that here. Do a test fit there. Still too small, so we keep going and just keep doing that until it works. And there we go. Now that one's fine too. So that looks pretty good. These don't fit perfectly because they sit over that ledge on the edge. They're a little bit on an angle, but that's okay. It's fine. Then I'll just clean up the top of that hole by going on an angle like this. Get rid of the burrs and stuff, and we're done with that. Right, so now I've got to fit this in here and see if it will actually fit in the case. Which it probably won't. It's a little bit too long, so we're about, I don't know how long that is, but I think if we were to put the nut on there, for example, even just that might be enough, but we'll see. Imagine I put the nut on here, put that on there, and now it's, well, not perfect, but it's almost perfect, so that might be good enough. So yeah, I just need to go steal the nuts off the other ones I have that are damaged, and just use that to push that up, lift that up a little bit, and then we'll have enough space for it to basically fit in the thing. Alright, so I've got the binding posts on, as you can see. Turns out I had these two broken ones here. You can see where I put thread tape on to try and fix it, but they were just too far gone. Unfortunately I only had one nut left, and didn't have two nuts, so I used one nut on the black one, and then on the red one I used a different nut from this old broken rotary switch from the decade resistance box that I fixed. So yeah, it's always a good idea to keep broken stuff sometimes, especially nuts and washers and things. I didn't actually use the split rings, ended up 3 spare, which I can probably use for something else, but yeah, the tension is just too great, and it looked like I was just going to strip these as well, so I didn't bother. So I've got the nuts on the bottom side and extra nuts here to get the clearance for in the case here. But yeah, I think that looks pretty good. They kind of stick up, kind of look a little bit silly how far they stick up, but you know, much more useful than the screw terminals, and not rusty for a start. So yeah, and they got the banana socket things on there, which are quite useful as well. So that will be good. So now all I should do is just solder those onto here, and that's about it. So I must take this back out of here. I've checked the clearance, it all seems fine. So I'm going to pull that back out of there and solder these wires on. I might actually have to trim these back and cut these parts off where it's full of stiff solder, because I need to kind of be able to wrap them around this post here and solder it on there. It's probably the best way of doing it. I think they should still be long enough. That would be the only reason to worry about, but these extend quite far. Whoops, out the front there, and you know, this is around here. So yeah, we've got a decent amount of space, I think, to work with. I think I will just cut these back a little bit. Yeah, that's a bit better. Let's see, where do we want the wires to actually go? I think we do want them to come out the front, so that will sit like this. Yeah, because these come up underneath, so we want to solder them, I think, from the front side. Have the wire coming out that way as much as possible. So yeah, we want to have that facing out the front there when it's soldered on. I think that makes the most sense. Let's try and do that. Of course, these solder posts are annoying. I probably should tin them first before I put the wire around it, actually. That's probably okay. Just wait for that to cool down. Yeah, I mean, that should be good enough. And then we do the same with the other one. Not perfect, but it gets the job done. I mean, this thing is already pretty janky anyway, as you can see from the whole kind of poor performance of it. So I'm not going to worry too much about how this looks. Right, so now we can put this back in the box now. Slot this transformer back in there. Let's see if that actually fits. It should do. Let's just put that down there. So that went to here, and if we were to put that on there, sort of just got to get these wires routed in a way that makes sense. So we get that back end on there, and that comes down here. Should be fairly good. It's not perfect by any means, but it's good enough. I don't like how tight the mains cord is at the back of this. It's very much sort of squashed in there as well, but I guess there's not a lot you can do about that. Right, well there we go. It's not perfect by any means, but it's certainly more usable. These binding posts are much more useful than those rusted screw terminal thingies. And yes, they just fit, which is nice. The case is a little bit coming up on the sides there slightly, I think. I think these may be a little bit too long, maybe like 1 millimeter or something. So they do kind of push on the case, but it's fine. The plastic can just bend a little bit. It's not a big deal. I will have a look at the regulator though, see if it fits in better if I do it a different way. Just looking at the heatsink again, this is a really poor design. I mean, not the poor design, but poor doing stuff with it. If you actually look at the heatsink where it's bent, you can see there's actually plenty of space for the regulator to be mounted and clear that bend part if it's mounted high enough. But on this they've mounted it too low and it's just there. So I think the issue really is you just need to take this hole and just enlarge the hole or re-drill it so it's up higher. And I think that should be fine. Probably will need to replace it with this one, so I've got the longer leads, because it needs to go up about 4mm or something, and these are probably not long enough to fit in there. So I think I might try and do that. Annoyingly, the heatsink is actually riveted to the PCB, so I can't easily just take it off and work on it that way. But who knows, we should be able to figure that out though. I mean, they've put like even a little star washer thing on here to hold the nut on the heatsink, but then they don't even have the regulator mounted against the heatsink properly. It's rather sad, really. You see the actual amount of thermal contact on that regulator was barely nothing. Yeah, I mean, they've got a bunch of heatsink compound on there, but most of it wasn't even touching the heatsink. In fact, practically none of it was. Because of the whole thing being in the wrong orientation. So if I was to drill that there, actually, yeah, I think I can get away with that. There's just enough space, I think, to drill another hole. That trim port doesn't look that great either. It's quite sort of corroded there too. The leads are all sort of tarnished, so who knows if that's even accurate anymore. Perhaps I need to replace that as well. So yeah, I just need to re-drill that. The only problem is trying to get it under my drill press. Yeah, if I fold that back, yeah, and hold it up like this, I think I can. I think I'll just have enough space where I can do that. I think we need what, a 3mm hole for an M3 screw. I think that's what that is. Either way, it doesn't matter. It's got a nut with it, so I don't need to worry about what type of screw it is. It will fit either way. Okay, let's drill this hole here. See if this will work. I think it should. Yeah. Yep. It's a little close to the top, but it has to be. Unfortunately, just the way this thing is. Right, just get those aluminium filings out of the way. Well, not filings as much as just drill swarf, I suppose, but either way. Right, so now let's remove that old regulator, which again is slightly cracked at the top, I think, which may be part of a problem with it. I don't know. Either way, let's just get a new one, shall we? The legs won't reach. Either way. Yep, okay, let's come out of there. We got the new regulator here. Obviously I need to bend the leads out as well. This heatsink has a kind of a rough spot just there. It's kind of sticking up. I might just sand that down a little bit to make sure it's nice and flat. The joys of shoddy quality stuff. But yeah, that's not going to help the heatsink, the regulator fit flush against the heatsink if we've got that, we've got some sort of dent in the heatsink that's got a rough edge. So I'm going to need to sand that down a bit. I should have done this before I did the binding post, it would be much easier, but oh well, that's just how it is. Let's see, so a little trick you can do if you want to sand a small area is get like a little strip of sandpaper and fold it at the end of like a little chopstick, so you've got like a little flat small bit, and you can go at just this little piece. Same as like a sanding block, I suppose, but just on a very small scale. Yeah, I just want to get rid of that little bit there. I also want to sand down where I've drilled, so that's nice and flat as well. And you can see, possibly, yeah, that little mark there just below the lower hole to the left. So I don't know what that was, but it was kind of raised up and sticking in that spot there, so that would also prevent the regulator from making decent contact, which is not great. That feels pretty flat now, so that's good. Now that I've put my finger all over it, I'll have to clean it off with alcohol. But anyway, and that should be okay. Brush around here to get rid of any dust. Alright, so now to clean this off and then finally actually put the thing on. Wouldn't that be amazing? Crazy I know, but there we go. Actually, it's quite hilarious. There was basically no transfer of the compound to that, and if you actually look on the original one, they put the heatsink compound at the bottom, but it was only just at the very top of the tab that was actually making contact with the heatsink, so basically all that heatsink paste was just sitting there doing absolutely nothing. Alright, now I got some alcohol here. I'll just wipe this down, make sure it's half decent there. I also wipe off the regulator itself, just to make sure there's no grease from fingers on it, to prevent the heatsink compound from going on properly. It's always important to make sure the surfaces are nice and clean. And yeah, and then you can add some heatsink compound. Doesn't have to be anything important. I've got just some basic stuff here from JCar. I don't know, I forget the catalogue number. You can buy it from JCar anyway. It's only a couple of dollars for a small tube. I think maybe I should shake it up a little bit. There we go. Now we've actually got the white stuff. Excellent. It's probably more than enough there. Let's try and get this into here. Put that on there. And get the screw in. Let's see. We had a screw, we have two star washer thingies, this other washer and a nut. So I think the screw went in first with one star washer from the back there, and then we had this big washer here which went on, and then another star washer, and then the nut. Now, of course, I'm mounting this to the heatsink first, because if you solder something like this in and then mount it to the heatsink, you're liable to crack the solder joints, because obviously it won't actually, it may not be fully aligned on the heatsink, and then when you tighten it down it pulls on the solder joints and cracks them. So at the very least it also could damage the lead of the component and, you know, crack it away from the body or something like that. So you really don't want to do that if you can help it. If you absolutely must solder it in first, I would solder it in very minimally, then screw it down and then reflow all the joints in that sort of circumstance. Annoyingly, we do have this big hole right behind the part here, but there's not much we can really do about that. In any case, it's obviously going to be a lot better than it was. The part is actually now flush against the heatsink instead of being pushed up at the bottom where the curve part is. And yeah, we actually have the thermal compound is actually now making contact with the thing. I'm just going to have to get rid of some of the stuff that's squeezed out the side. Now let's put that back in the case and give it another test and see what it's like now. Of course I do have to solder this in, of course. Getting ahead of myself. What am I doing? I need to solder the new regulator in, otherwise absolutely nothing will happen. It's kind of lunchtime and I need to finish this. Obviously my brain is not working properly. These crocodile clips are rubbish. I need to get new ones. This one's quite good. Some of these are not very good. I need to redo my test leads. They're old crusty ones that I inherited, and they're not actually that great. Let's plug it in and see what happens. Let's see, what do we get? 5.8. Put that back down to the 3. Well, it's 3 volts, it's now 2.9, which is a much much more accurate than what it was before, at least on the 3 volt position anyway. Let's turn the load current up a little bit. Let's see. It still drops a decent amount, I guess. I don't know. It's probably just the transformer is just not very good. Or maybe that bridge rectifier is running quite hot. And yeah, it actually is running really hot at like full load. I don't like that much. It's kind of terrible. You get about 300 milliamps out of it before the voltage kind of drops. 400. Yeah, too much. Let's try the 6 volt position. Well, that's 5.8. Again, a little bit low, but I guess that's just the resistors in here are probably not perfect. They don't even look like 1% ones. That's just a 5% resistor. So the resistors on the adjustment pin aren't even that great. And we've got, let's see, 9 volts. Again, that's like 8.7. And then 12 is... It's pretty low, honestly. It's not great. Yeah, it's only like 3 volts that's actually pretty much accurate. All the rest are kind of low. I guess we can adjust the voltage with the trim pot, but then of course that'll put the 3 volts off, I suppose. The others might go up, but then the 3 volt will be probably too high. Might end up being a little bit more than you want. I think it's good enough to use as a basic thing for just quickly testing things and stuff like that. I don't think it's really worth putting more money into it, although the resistors, replacing them with 1% precision ones would not cost much, so that might be something I'll do later on. Maybe getting a better trim pot. A 10-turn one would make more sense, but like I said, the whole thing is rather cheap and basic anyway, so I don't know it's really worth spending the money. It looks like it's good for about 300-400 milliamps before the output starts dropping significantly. Could be the transformer, could be the rectifier. I'm not sure what's actually the problem there, but I'd say it's probably good enough for now, really, to be honest. Like I said, it does work now, at the very least. It works well enough to be usable for mucking around with hobbyist stuff, so I think I'll just keep it as is at this point. If I do decide to adjust it later, yeah, I mean, it would just be a case of adding better resistors, replacing the resistors with more precisional ones, maybe the trim pot, that sort of thing. It's not really that complicated. It's not worth really showing in a second video or anything, but there we go. I mean, the thing does work. It had some issues. It still has some issues. Obviously, the mounting for the regulator, having that half off the heatsink, and or mostly off the heatsink, really, was absolutely terrible. Poor manufacturing, poor build quality. I don't know. They drilled the hole in that heatsink in a very odd place, too low down. I don't know why they did that. Yeah, very odd. I wonder how many of these are out there, or were out there, that were like that, and then maybe the regulator failed because it overheated. Although it looks like the bridge rectifier is more likely to fail first because it has no heatsink and it gets very hot. I think, yes, it is possible I'll come back later, and if I have issues with it, I'll replace that rectifier with something a bit more useful, and probably attach it to the heatsink as well. Might be a good idea, or even give it its own one if you can fit one in there somehow. But other than that, though, there's not much else to do with it, I guess. It's certainly much more improved than what it was when I got it, I would say. So, you know, I'm quite happy with how it is. I've just got to put it back together. Obviously with these, the standard thing applies. Put them in the hole, turn them backwards until they click into the threads, and then screw them in. So you're not cross-threading them or chewing out the thread by putting it in an incorrect way. Always the case with these kind of things. And don't over tighten them, because again, soft plastic. I may come back later and put a power indicator LED in here if I can be bothered, but other than that, I think it's basically done. It certainly is improved from how it was previously, and yeah, it's actually useful now. And we don't have a bridge rectifier in there with a giant crack on the side, or a regulator that's not even mounted at the heatsink properly. Very interesting. Yes. I'm kind of saddened by that, to be honest. I wish this had been made better, but there you go. I don't know how much this thing cost new. I could probably look it up and find out, possibly. But yeah, you wouldn't have thought that it would be that cheap, and you'd hope that the build quality and everything would be a little bit better than that. But I guess not. That's just the way it is. But there we have it. If you do have one of these yourself, and you're having issues with it, if it doesn't work or something, well, there you go. There's a list of things to check and look at and play around with. Certainly check the heatsink. Make sure that thing's mounted properly. It's a bit sad otherwise. Anyway, hopefully that was interesting. Hopefully that was useful. Sorry it probably went on for far longer than it needed to. But hey, it's fun making videos like this. Just taking a couple of hours to just relax and fix up something that's in a bit of need of a little bit of fixing up. But yeah, that should be a useful thing to keep around the bench. I'm sure I can find some uses for it at some point. I may improve it a bit more later on, as I mentioned, with possibly resistor changes or something like that. Maybe even adding an adjustment knob. I don't know. But yeah, that's nothing particularly interesting or complicated, so I won't bother talking about it here, or I won't show it here. I don't know. We'll see what happens. But for now, that's about it. I'm sure you can imagine what that would look like if I did it. But that's that. Hopefully that was interesting. Hopefully that was useful, and I'll see you next time.